Hello, science fans! Welcome back to the channel. Today we're diving headfirst into one of nature's most powerful, destructive, and awe-inspiring phenomena: tornadoes. These swirling behemoths of wind and fury capture our attention and respect like few other weather events can. Imagine a giant spinning top, but instead of plastic, it's made of wind, rain, and all sorts of debris picked up along its path. Tornadoes are the ultimate display of atmospheric energy, a testament to the sheer force that our planet's weather systems can unleash. They are nature's raw power on full display. They're a raw demonstration of physics in action, a real-world example of the forces that shape our world. Tornadoes are a complex interplay, combining thermodynamics, fluid dynamics, and atmospheric science into one destructive package. Understanding them requires a grasp of all these fields. When the right mix of air masses, temperatures, and pressures collide in just the right way, creating instability in the atmosphere, a tornado is born, a cosmic dance of nature, a violent ballet performed by the elements. It's a moment of both destruction and awe. Tornadoes can be brief and small, lasting only a few moments and causing minimal damage, or they can be massive and long-lasting, carving paths of destruction and reshaping landscapes in minutes. Each tornado is a unique experiment, a natural laboratory revealing the secrets of our atmosphere and the forces at play within it. By studying them, by analyzing their behavior and the conditions that create them, we not only learn how to stay safe and protect our communities, but also unlock the mysteries of Earth's dynamic systems, gaining a deeper understanding of the complex processes that govern our planet's weather. So in this video, let's break down exactly what tornadoes are, how they get their incredible power, and where they are most likely to strike. We'll explore the cutting-edge science behind predicting these powerful storms, looking at the tools and techniques meteorologists use to give us advance warning. And most importantly, we'll discuss how to stay safe when the winds start to swirl and the sirens begin to wail, ensuring you and your loved ones are prepared. Understanding the science behind tornadoes makes these storms less frightening and a lot more fascinating, allowing us to appreciate the power and complexity of nature. So buckle up, hold on tight, and let's get started on this whirlwind tour of tornado science. How does a tornado form? What are the key ingredients and atmospheric conditions that lead to the birth of these powerful and destructive forces of nature? Let's break down the science behind tornado formation, step by step, to understand how these awe-inspiring phenomena come to life. It all starts with a supercell thunderstorm, a regular storm, supercharged. These aren't your average rain clouds. Supercells are intense, rotating thunderstorms that possess a unique structure and the potential to produce severe weather, including tornadoes. The recipe: warm, moist air near the ground. This warm, humid air acts as the fuel for the storm, providing the energy needed to sustain its powerful updrafts and rotation. Think of it as the gasoline that powers the tornado engine. Cool, dry air above. This creates instability in the atmosphere, as the warm air rises rapidly while the cool air sinks. This contrast in temperature is crucial for the development of strong updrafts and wind shear, winds blowing at different speeds and directions at different altitudes. This is a critical ingredient. Wind shear causes the air to rotate, setting the stage for the formation of a mesocyclone. This creates a horizontal spinning tube of air, like rolling a pencil between your hands. This invisible vortex is the precursor to the tornado's rotation. When a strong updraft tilts the spinning air vertical, lifting it from the horizontal plane, it forms a mesocyclone, the storm's rotating heart. This is a region of rotating air within the supercell thunderstorm, and it's where tornadoes are most likely to form. Not all mesocyclones make tornadoes. They can exist without ever producing a tornado, but all major tornadoes come from them. The presence of a mesocyclone significantly increases the likelihood of a tornado developing. As the mesocyclone narrows and stretches, intensifying its rotation, it spins faster, like a figure skater pulling in their arms to increase their spin rate. This is the conservation of angular momentum in action, a fundamental principle of physics that explains why the rotation speeds up as the rotating column shrinks. A visible funnel cloud forms, a condensation cloud made up of water droplets, as the rotation intensifies and descends from the cloud base towards the ground. When that funnel touches the ground, kicking up debris and dust, a tornado is born, a violent rotating column of air extending from the thunderstorm to the ground. All these ingredients, warm air, wind shear, and updrafts, working in perfect, albeit destructive harmony, combine to unleash one of nature's most spectacular and potentially devastating forces. It's not magic, it's science in motion, a complex interplay of atmospheric dynamics and thermodynamics. Every tornado is a dramatic demonstration of physics at work, showcasing the power of atmospheric instability and rotation. That's the incredible process behind every twister, from the initial storm development to the formation of a fully fledged tornado. Science! Tornadoes, those swirling vortexes of nature's fury, are truly a sight to behold. They manifest in a stunning array of shapes and sizes, each one a unique display of atmospheric power. And when it comes to sheer destructive force, some tornadoes have etched their names in history by setting jaw-dropping, almost unbelievable records. These are the titans of the tornado world. To categorize these forces of nature, the enhanced Fujita scale was developed. It's a system that rates tornadoes based on the damage they inflict, starting from EF0, which indicates light damage, all the way up to EF5, reserved for instances of incredible destruction, where structures are completely obliterated and landscapes are irrevocably altered. EF5 tornadoes are the apex predators of the storm world, packing winds that can exceed a staggering 200 miles per hour. These winds are capable of leveling homes and turning debris into deadly projectiles. Speaking of records, the infamous tri-state tornado of 1925 holds a particularly grim one. This monster storm carved a path of destruction for an unbelievable 219 miles, tearing across 3 states. And it didn't just travel far, it lasted for over 3 hours, leaving communities devastated in its wake. That duration record remains unbroken to this day, a testament to its terrifying longevity. But what about the sheer size of these storms, the widest tornado ever recorded? That title belongs to the El Reno, Oklahoma tornado of 2013. At its peak, it measured an astonishing 2.6 miles wide. To put that into perspective, that's wider than the entire island of Manhattan. Imagine a tornado that could engulf one of the world's most famous cities. Beyond their size and strength, tornadoes are also known for their capacity to do bizarre and unpredictable things. They can perform feats of seemingly impossible strength, like effortlessly tossing train cars off their tracks, or plucking personal items from homes and sending them on journeys of hundreds of miles, scattering memories across the landscape. In terms of appearance, some tornadoes take on a slender, rope-like form, almost like a swirling strand of smoke, while others are multi-vortex monsters, complex systems of swirling chaos. These multi-vortex tornadoes feature several smaller funnels, or satellite tornadoes, all spinning furiously around a central core, amplifying the overall destructive power. It's important to remember that even seemingly small tornadoes can pose a significant danger and should never be underestimated. But it's the largest tornadoes, the EF5s, that truly capture our attention and inspire a sense of awe, and perhaps a little fear. Every tornado, regardless of its size or intensity, serves as a valuable learning opportunity. Each one provides scientists with crucial data, helping us to better understand the complex and often unpredictable physics that govern our atmosphere. Ultimately, tornadoes are a stark reminder of the immense power of nature and its inherent unpredictability. They demand our respect and vigilance. And the ongoing scientific quest to unravel the mysteries of tornado formation is just as captivating as the storms themselves. Tornadoes can strike almost anywhere, but the U.S. is the world's tornado hotspot, averaging over 1,200 per year. The perfect setup: warm, moist Gulf air meets cool, dry air from the Rockies and Canada, with no mountains to block the collision. This creates Tornado Alley: Texas, Oklahoma, Kansas, Nebraska, and South Dakota, where powerful storms are common, especially in spring and early summer. Dixie Alley in the southeast, Mississippi, Alabama, Tennessee, Georgia, also sees frequent, often dangerous tornadoes, sometimes at night or hidden by rain. Tornadoes can happen any time of year, day or night, if the conditions are right. That's why weather awareness is crucial, no matter where you live. Knowing your region's tornado season helps you stay prepared. Science and vigilance go hand in hand. Stay alert. Nature doesn't keep a schedule. Predicting tornadoes is a triumph of modern meteorology. Meteorologists use weather balloons, ground stations, and advanced computer models to monitor the atmosphere. Doppler radar is key. It detects not just rain, but the motion of raindrops and debris, revealing storm rotation. A hook echo or a tornado vortex signature on radar signals a tornado may be forming or already on the ground. When conditions look dangerous, meteorologists issue 2 alerts: a tornado watch, be prepared, and a tornado warning, take shelter now. These warnings save lives by giving people precious minutes to act. Technology and science work together to keep us safe. Staying informed is your best defense. The science of prediction is always advancing. Preparation is your best defense against tornadoes. Make a family plan, know your safest spot, preferably a basement or interior room on the lowest floor, away from windows. Practice getting there quickly so everyone knows what to do. Build a disaster kit: water, non-perishable food, flashlight, batteries, first aid supplies, weather radio, and necessary medications. Stay informed. Know the difference between a tornado watch and warning, and sign up for emergency alerts. Identify safe places at work or school ahead of time. Secure outdoor items and trim weak branches to reduce flying debris. Preparation is about thinking ahead and using science to stay safe. A solid plan brings peace of mind when storms threaten. Be ready. Knowledge saves lives. When a tornado warning is issued, act fast. Get to your safe place immediately. Don't go outside to watch or take photos. Tornadoes can be hidden by rain or darkness. In your shelter, get low and cover your head and neck. Use a mattress, blankets, or helmet for extra protection. Stay away from windows and put as many walls between you and the outside as possible. If you're in a car or mobile home, get out and find a sturdy building. If that's not possible, lie flat in a ditch, covering your head. In public buildings, follow emergency procedures and avoid large open rooms. Stay calm, listen for updates, and don't leave your shelter until it's safe. Your preparation pays off in these critical moments. Quick action and clear thinking save lives. Safety first, always. After the tornado passes, danger isn't over. Be cautious. Check on family and neighbors, but don't move the seriously injured unless necessary. Watch for downed power lines, broken glass, and unstable structures. Wear sturdy shoes and avoid damaged buildings if you smell gas or hear hissing. Leave immediately and call for help. Keep listening to weather updates and follow official instructions. Use phones only for emergencies. Text if possible. Stay out of the way of emergency crews and avoid unnecessary driving. Document property damage for insurance before cleanup. Recovery takes time, but careful steps and community support make it safer. Science and caution guide the way forward. Tornadoes are one of science's most captivating mysteries, and our understanding keeps growing. Thanks to Doppler radar, computer models, and dedicated scientists, warning times have improved, and lives are saved. Safety science, having a plan and knowing what to do, empowers everyone. Researchers are using new tech like mobile radar and drones to unlock tornado secrets. Every storm teaches us more, and better forecasts are on the horizon. Technology is only part of the solution. The other part is you. Stay curious, stay informed, and take preparation seriously. By understanding the science, you become part of the safety equation. Keep asking questions. Science is awesome. The future of tornado safety is brighter than ever.